Hi class, and welcome to our video lesson on 9-1. This is titled Multiplying Rational Expressions, which is a kind of a fancy way of saying multiplying fractions together. There's a lot of similarities to what you learned in elementary school. It's obviously more complex, but the same concepts still apply. If we were to take the number 2/3 multiplied by 15/8, for example, it's a fraction times a fraction. You multiply the numerators by each other, you get 30, and you multiply the denominators by each other, and then you get 24. And then at the end, if you can reduce, make sure you do that. This one we could divide both top and bottom by 6, so we get the answer 5/4. 5/4 is our answer. We circle that, we move on to the next one. There's one big thing that we can keep in mind that is also true of rational expressions, is we can do what is called cross-reducing. If you have 2/3 times 15/8, we can reduce these before we even multiply to make them easier numbers, such as 2/8 reduces to 1/4. 15/3 reduces to 5/1. And now you can multiply the numerators. 1 times 5 is 5, and 1 times 4 is 4. So we get 5/4. Either way, we get the right answer. So those are key concepts that we want to remember as we now multiply rational expressions, which now have variables in them. So let's first simplify this one. We could simplify from top to bottom. 21/14 is 3/2. X squared divided by x squared, anything divided by itself is just 1, so those cancel out. And then we have y cubed divided by y to the first. You would subtract those exponents. 3 minus 1 is y squared. So we end up having 3y squared in the numerator, and in the denominator we end up with 2. 3y squared divided by 2 is the correct answer for number 1. So now for problem number 2, we could square the numerator and then square the denominator and then reduce, or we can reduce first and then square everything at the end. I think it's easier to reduce first because then you get smaller numbers. So this becomes 1/2. So we have 1/2. X squared and x to the fourth makes an x squared on the bottom. And then you only have a y, so that stays in the numerator. And then z cubed divided by z to the first is z squared. So now you have this, all of that is still squared. So now we're going to square the numerator. 1 squared is still just 1. Y squared is y squared. Remember, when you have a power raised to a power, you multiply. So 1 times 2 is y squared 2. Z squared squared, you'd multiply the 2 by this 2, and you would get z to the fourth. There's your numerator. Denominator, you'd square your coefficient. 2 squared is 4. And then you would square your x squared, power raised to a power. You'd multiply again, and you would get x raised to the fourth. You can't reduce any further, so there is your answer. Y squared z to the fourth over 4x to the fourth. Excel math won't have these answers in there, that coefficient of 1. It's just going to be left like that. Problem number 3. Now we're going to get into where we can cross-reduce. 7/21 is 1/3. 8/16 is 1/2. X divided by x cubed leaves an x squared in the bottom. Y squared, y cubed leaves a y to the first in the bottom. So now in the numerator, all you have left is 1s. So you have a 1 left in the numerator. And in the denominator, you have 3 times 2, which gives 6. And you have a y and an x squared. We always write these in alphabetical order. So x squared would come first. The y would come second. 1/6 x squared y. There's our answer for problem number 3. Number 4, moving right along, why don't you guys pause the video and try this one on your own. When you try this one on your own, you saw that 5/15 is 1/3, and you saw that 12/24 is 2/1. Then you start canceling some letters, so a to the fourth and a cubed is a to the first in the numerator. So here's our a to the first. Let's see here. Anything else? This b and this b can cancel out because anything divided by itself is just 1. And I believe that's all the reducing that we can do. So we have 1 times 2, so our coefficient is 2. We have an a right here, and we have a c and a c squared. When you multiply those two, you would get c cubed. So 2ac cubed in the numerator. In the denominator, you have 1 times 3, which gives 3. And you just have this b squared left in the denominator. So 2ac cubed divided by 3b squared. Hopefully you all got that for number 4 when you did that one on your own. Problem number 5 looks like this. Whenever we have factors, we can reduce them. So this is a factor, 3y. It can be canceled with other 3y's. Now this right here is a factor. It's y plus 7. And this y plus 7 can be reduced with other y plus 7's. So anything divided by itself is 1. So y plus 7 divided by y plus 7, that's gone. So now in the numerator, we have 3y. And then in the denominator, we have y squared minus 9. Now class, this is our answer for this one. We cannot reduce 3 and 9 to make 1/3. That's mathematically illegal. The reason why is because you could only reduce factors. So this right here is a whole factor, and you can't reduce part of factors. You have to reduce the whole factor, which means multiplying. Factor is multiplying, and now this minus 9 means subtracting. So you can't reduce when you're multiplying something and subtracting something. That's mathematically illegal to do. I want you to be aware you could have this. If anyone recognized this as being the difference of two squares, it's 3y over y minus 3 times y plus 3. So you could have this as your answer as well. Excel Math might have that. I'll accept either one on our chapter test. But again, you can't reduce this and this because this is a factor. It's 3 times y. Where this y isn't a factor, it's y minus 3. That's the whole factor is y minus 3. So if you want to, you can reduce the whole factor of y minus 3. However, we don't have a y minus 3 in the numerator. So this is our answer. We'll get more practice with that as we go forward. Trying the next one. In the numerator, I could take out a GCF. It's 5 times the quantity y minus 2. So I have one factor of a 5, and I have one factor of a y minus 2. In the denominator, I could also take out a GCF. That GCF is going to be a 15, and I could also take out a y. 15y times the quantity y minus 2. So in the denominator, I have 3 factors. I have 3 things multiplied by each other. 1, 2, 3. So I can always reduce factors. So here's one factor, and here's another factor. They are the exact same thing. Bam, they reduce. Here's a factor of 5, and here's a factor of 15, so those reduce. 1/3. So in the numerator, all I'm left with is 1, and in the denominator, I am left with 3y. This is why this is called simplifying, class, because what is simpler, or what is smaller? To say this, or to say this? Obviously, the 1 over 3y is a much more simplified way of saying the expression. On to problem number 7. Why don't you guys pause the video and try this one on your own. Once you try this one on your own, you found out that when you take out a GCF of a to the 4th in the numerator, you got b minus 2 as your other factor. A to the 4th and b minus 2. And then in the denominator, you took out a GCF of a cubed. And then you are left with a 2 and a minus b. So now when we reduce this one, a to the 4th divided by a cubed is a to the 1st. So in the numerator, you have a times b minus 2. And in the denominator, you have 2 minus b. Now, it might be very tempting to go like this, class. Hi-ya! But you cannot do that. Because this one right here is a positive b, where this is a negative b. And this is a negative 2, and this is a positive 2. So they aren't the exact same binomial. The factors are not the exact same. However, you can take another step. You can take a negative 1 out of this. If you take a negative 1 out of the denominator, watch what happens. I'm factoring out a negative 1. So in my numerator, I still have A times the quantity B minus 2. In the denominator now, I'm taking out a negative 1. So what's 2 divided by a negative 1? A negative 2. What's a negative B divided by a negative 1? A positive B. So I took out a negative 1. It's kind of like taking out a GCF. I took out a negative 1, and now I'm left with a positive B and a minus 2. Hence that factor. Now I can go bam, bam. Good stuff, right? So now it's A divided by a negative 1. And what's A divided by a negative 1? A negative A. My answer used to be this junk. Then I simplified it, and bam, I got a negative A. Much, much more simple. Let's try number 8 now. Number 8, we can take out the GCF of 2x squared. And then I'm left with an x and a positive 3. In the denominator, I can take out a negative 6x. I take out a negative 6 from this first term, and I'm left with x. I take out a negative 6x from this term, and I'm left with a positive 3. So there's our factors. We can reduce factors that are the same. X plus 3, those cancel out. They've reduced. X squared divided by x reduces, and it leaves x to the first. 2/6 is 1/3. So now in the numerator I have 1x, or just x, and in the denominator I have a negative 3. X divided by a negative 3 is my answer here. Just to let you know, class, you might see this, a negative x divided by a positive 3. That's also saying the exact same thing. If they move the negative sign to the top, it's kind of like saying what's 10 divided by a negative 2? It's a negative 5. Or what's a negative 10 divided by a positive 2? It's still a negative 5. So whether the negative sign is in the numerator or the denominator really doesn't change the results. And that's what we're saying on this one. So just be aware, Excel Math might have either of these two. Be aware of that. Number 9 and 10 are the funnest ones in the all of advanced algebra because they are so much fun to reduce common factors. Right now we have a mess. It's a bunch of garbage. Let's clean it up, and we're going to do that by factoring. So we're going to factor not once, not twice, but we're going to factor 4 times, and it's going to be awesome. So let's do this thing. X times x minus 3 and a positive 2. If you like factoring, you're going to love these. If you hate factoring, you're going to hate these. X plus 3, x plus 1. X plus 2, x plus 1. X minus 5, x minus 3. Once you have them all successfully factored, now you can reduce factors that are the exact same. So x minus 3, hiya! X minus 3, hiya! You're done, son. Now we have x plus 1 can cancel with this x plus 1. Those are gone. And that's all the more factoring that we can do. That was fun though, wasn't it? That was a great time. So in the numerator, I have 2 factors of x plus 2 times x plus 2. And in the denominator, we have 2 factors of x plus 3 divided by x minus 5. And there's our answer for this problem. Just to let you know, again, you might see a different answer if it was x plus 2 quantity squared over x plus 3 and x minus 5. They mean the exact same thing, so you could have either of those 2 answers on your next chapter test. Alright, you guys pause the video, try number 10 on your own. You tried number 10 and you had a great time because you factored a bunch of times. We're going to factor this, and we're going to have 3x and 1x. And we're going to have a positive 3 here and a positive 2 there. Because there's your 9x plus 2x, there's our 11x. Boom cha. Hopefully you guys saw that you could take a GCF out of this. So it's 4 times the quantity, x squared minus an x minus 2. And then you have a trinomial, and that factors into these. So x and x, x minus 2, and x plus 1. So this right here becomes this right here when you factor it. Again, you have a greatest common factor of a 2 that you could take out, and it's x squared minus 3x plus 2, which again can factor into 2 more binomials, x and x minus 2 and a minus 1. And then in the denominator, we have x times the quantity. Oh, sorry about that. We can't take a GCF out of this one, so we just have two binomials, x and x minus 3 and a minus 1. Whoop, x minus 3 and x plus 1. There we are. Now we have all of our factors, so let's start reducing factors that are the exact same. Here we go. X minus 2 and x minus 2, those reduce. That was fun. Is that it? Boy, I thought for sure there was another one. Oh, rats! Sorry about that, class. Stink. This should have been x plus 3 and x minus 1. There we go. And then this x plus 3 cancels with this x plus 3. And this x minus 1 cancels with this x minus 1. Woo! Okay. So now, oh, we have one more factor. The coefficient of 2 and the coefficient of 4 reduce to 1/2. Oh man, what a roller coaster. So we have this factor left up on top with this factor. So 2 times the quantity, 3x plus 2. 2 times the quantity, 3x plus 2. And in the denominator, I'm left with, oopsie, this reduced. I'm sorry, so that should be a 1 right there. So all we have left in the numerator is 3x plus 2. And then in the denominator, you have this 2 and this x plus 1. 2 times the quantity, x plus 1. There is your answer for problem number 10. Be sure to let me know if you have any questions on this when you get to class tomorrow.